My name's Professor Graham Galbraith, I'm the Vice-Chancellor of the University, and it is a real pleasure to welcome so many engineers to the University this Friday evening. And it is a Friday evening, so that shows real dedication, I must say, in turning out for this event. And it's a real pleasure to have so many welcome guests, and I believe the format this evening is going to be something rather interesting and different, and I think it's always good in the University of Portsmouth to try something new for the first time, and I think it is a new format for IMechE. And of course, as an engineer, it is really nice for me to be welcoming you. I think, from my point of view, the rhetoric in government over the last few years has been something that is a real welcome, I think, to everybody in the engineering community. The fact that at last there is a recognition of the work that engineers do and their contribution to the development of society. And I think for us at the university, that has led to much greater interest in studying engineering, and I think even in schools in now studying the underpinning maths and physics that are necessary if someone wants to pursue an engineering degree. You will have seen the student car out there. I'm always very proud of the fact that studying at a university like the University of Portsmouth is not just about academic study, it's also about those practical skills, those real life skills that make a difference, that actually stand engineers aside, I think, from other individuals who study science, that it's really practical. And I think our students who are here today do a fantastic job for us, and I'm very proud of what they achieve. Now, that's all I'm doing here tonight, is giving you a welcome, because I now want to pass over to Jason Crouch, who will give you more details about what's ahead for us this evening. So, Jason.
So I'm Jason Crouch. I'm the person behind all the spam you've been receiving. But thank you for responding to it and coming tonight. And in fact, as organiser of the event, and on behalf of the Institution of Mechanical Engineers, Portsmouth and Isle of Wight Area Committee, I'd like to thank Graham and the University of Portsmouth for hosting us tonight in our flagship event for this year, and in your newly refurbished lecture theatre here. And also for hosting us, probably unbeknownst to him, on many of our normal event nights in slightly smaller accommodation. We thank you also for the faculty, staff and the university students who've turned out on a Friday night here to join us and showing their interest in supporting us. Also like to thank members of our own institution and sister institutions. The representatives have come from as far as Bournemouth, Boscombe and Brighton, so welcome all, and staff and students from other universities and sixth formers from local schools and colleges who are here as well. And moreover, as part of the sort of technology that we're trying out today, we're running an audio stream on the net, so welcome to all those from listening from parts further afield than that. Now, this event, we're hoping to build a number of bridges and start relationships with some of these other, with ourselves and the other professional bodies at the local and regional level. Hopefully we can have some more joint events, perhaps not quite on this scale, but please, if you're interested in that, please share your details with our committee, with the ones with the green badges. Now, I have mentioned that we're novices in some of this technology, and you're guinea pigs, and so we've been using it in the run-up to to this debate, and we're actually going to be using it during the debate to take your questions and to follow up with you afterwards. We strongly encourage you to use the Twitter and Facebook to do that. Those people who've submitted questions on using the postcards downstairs, and our committee members will have typed those in, so you'll have that, and they'll when you're called, please use the question that you've got to or that you've submitted to yes. Okay, so if we like your question best, then that'll be passed to the chairman, and you'll be called out. Put your hand up. The ladies with the microphones will come and find you. Right, and that segues very neatly to the main part of our event. And lastly, but certainly not least, I'd like to personally thank both the speakers for responding to my invitation to join us here, and particularly for Colin, our chairman, who's going to do those introductions. So Colin, who's Director of Engineering at the Institution of Mechanical Engineers, over to you. Thank you very much.
Good evening, everyone. Let's get going. This is going to be a discussion this evening, so although we have two speakers, it's not my intention to make this confrontational in any way. It's intended, although I might try the odd bit now and again, can't resist. But the idea is that we inform you, that we get these informed views. These are very eloquent and well-read speakers, and we get you thinking about this because after this event we want you to go out and do something different to what you have done in the past. So the idea is to inspire and excite you. I just want to check, is there anybody in the room here, and for those of you at home, please put your hands up, we won't be able to tell, but is there anybody in the room who's not an engineer or planning to be an engineer? Oh, excellent, excellent. Well, I will be coming to you later on, because not to pressurize you, but I think one of the issues that we do have as engineers is we spend a lot of time talking to each other, and it does absolutely no good whatsoever. We've got to spend a lot more time talking to non-engineers and discussing the value of engineering. So I'm delighted that you're here tonight, and I look forward to hearing what you've got to say. The subtitle to this evening's discussion is called The Importance of Engineering to Society's Future and the Need to Support the Formation of the Next Generation of Engineers. It's quite a long title, and actually there's a paradox in there, isn't there, that if the engineering is important to society, and particularly as we have somebody from the right, political right speaking this evening, why on earth do we need to support the formation of the next generation of engineers? Surely the free market would do that if engineering was important to society's future. So I don't want to give away my early questions. You will have a chance to ask questions. I'm intending that you're going to take as much active role in this as I am. We have the roving mics. We have some planted questions to make sure that it doesn't go deathly quiet for the people lifting from it. So let me introduce the first speaker. We have here the Director of Engineering and Education at the Royal Academy of Engineering. He has responsibility for the diversity work of the Academy. He has the education policy and the research activity and all of the education programme. He also does teachers, CPD, and curriculum resource materials. He also oversees the Collaborative Education Alliances, which the Academy hosts, Education for Engineering, and the 36 professional engineering institutions, the Engineering Council, Engineering UK, as well as his own work. There's now a new UK forum for computing education called UK Force, which brings together the organisations in computing education. I don't quite know how he finds time to come along this evening, but please welcome Dr. Rhys Morgan.
Thank you, Colin. David Willetts and I both breathed a sigh of relief for about 3 seconds when you said it wouldn't be a combative debate, and then you said you'd throw in some bombs, so we're suddenly on edge again. Colin's right, the title for this evening is quite long. It's actually almost filled up my whole of my front title page. So what I want to do is spend 10 minutes or so. I'm going to rattle through some slides for you with some information about the contribution of engineers to the economy and some of the issues we face in producing the next generation of engineers going forward. So what do engineers do? This is the first question I want to ask you. So this is a CBBC's program called Nina and the Neurons. I don't know if any of you got little kids. My daughters love this program. Nina says that engineers build the world around us. They use science to solve problems. Actually, I think it's a really good kind of description of what engineers do for children and actually for some adults who don't want any particularly detailed description of what engineers do, because I think what we tend to do as engineers is overcomplicate things too quickly. And actually, for the majority of people, this actually works. Maybe we could put in a bit of creativity and problem solving in there. But actually, this is what we do. We help build the world around us. And we do that through various ways. The engineering in the UK contributes to about 30% of the value of the economy. And we can see that in the usual sectors such as manufacturing, construction, utilities, and computing and telecoms. So it's about 30%, it's about £300 billion of the value added, gross value added of the economy. But that's just the engineering that we can see. Now, we do know that engineers and engineering contributes in the other sector, the rest of the economy, in retail, in healthcare, in education, in arts, in entertainment, all these different sectors. Engineering is actually underpinning a lot of the work that goes on there as well. Within the footprint that we can recognise, engineering contributes to about 500,000 companies. So there are about 500,000 engineering companies in the UK across, again, manufacturing, construction, information and communication technologies, and various other industrial groups. But it's the contribution of engineers hidden in society, hidden in the economy, that I'm particularly interested in. The government has a labour force survey, the annual population survey, and that's where people say what jobs they do. And in that population survey, there are about 28 million people working in the economy. And of those, about 10%, 2.7 million, declare themselves on the form as being engineers. But we know there are lots of jobs going on that are actually engineering jobs, but the people are they're not declaring themselves as engineers. So actually, we think there's about another 1.5 million, 1.6 million jobs in the economy that are engineering jobs, but the people themselves don't recognise themselves as engineers, particularly in areas like IT and computing, where they see themselves as coders or working in technology, but they don't see themselves as engineers. And that's a bit of an issue for us. So we think in total it's about 15% of engineering workers in the economy. And these people are all over the place. So they're working, of course, they're working in the construction sector. So where you see these big dark red blobs, that's where there's a high proportion of engineers working in the sector. So, of course, we see them in construction, in manufacturing, in computing and telecoms and electronic technologies as well. But we see them in other areas such as media and publishing, in business services. So this is a lot of consultancy and research activity and so on. Food and drink manufacturing. We think about the manufacturing of food. It's a huge area of the economy that is supplied by engineering. But then there are engineers working in all these other little areas as well. There's not a high concentration of them, but they are there. And so where we see these blobs above this dotted line on this graph, that's actually where we're going to see increasing number of engineers, a prospective number of growth over the next 10 years. Actually the next 6 years, going to 2020. So what does that mean? Well, it actually means that taking the kind of the current number of engineers and looking at the predicted growth, we need about 1 million engineers by 2020. And that's at all levels. That's technician engineers and graduate professional engineers. And our current supply of graduate engineers here in the red suggests that we'll get to about 170,000 graduates by 2020 and about 200,000 technicians. So we are a long way short of meeting our demand, the supply needed for this predicted demand. And many of our industry representatives, many of the major companies, will actually say that this is an underestimate, this is a very conservative estimate of the current engineering skills demand. So, what's the problem? Well, the problem is that we have a pipeline of engineering skills, the children coming through, the young people coming through, that starts to shrink at every single stage. So typically in a single year, we have about 650,000 pupils in schools in England. And those students take GCSEs, and of those students, about half will get GCSEs in mathematics and in science, in 2 sciences. That's at grade C or above. So the very first hurdle we put in place for young people, we reduce our potential pool of workers by a half. Then it comes to choosing what subjects they might do after 16. Now, when it comes to when it comes to A-levels, when it comes to academic qualifications, only about 28,000 of those 300,000 will choose to do A-levels in mathematics and physics. Now, for many university courses, those are prerequisite subjects for engineering. There are, of course, other routes as well. When we get to university, so when the students have done their A-levels, actually about half of those 28,000 pupils will go on to, those students will go on to do engineering and higher education. So the UK population of engineering students every year is typically about 14,000. And that's bolstered then by EU students and international students. But then we have another problem, which is that some of our engineering graduates choose not to go into engineering jobs as well. So we end up with a population of about 8,000 to 9,000 graduate engineers choosing to go into professional engineering jobs. So you can see the seriousness of the situation where we lose all these people through the system. Now, like good engineers, we make sure there's another route, another pipeline to get to the flow moving. And this is our vocational pipeline. So this is where we actually start to look at apprenticeships and vocational routes as well. And I'll come back to apprenticeships in a little while. So looking at the kind of degrees we have in the UK, this is a trend of engineering first degrees over the last 10 years or so. And you can see that the blue line, the largest line, actually that's the UK domiciled, has remained largely static across that period. It dipped for a while and it started to rise. Where we've seen significant growth actually is in the international students, the non-EU international students. But of course we have this current situation where immigration policy is not allowing those students to work very easily in the UK after they graduate. When we look at the individual disciplines within engineering, we see that there's a variety of things happening. In mechanical engineering and civil engineering, actually we've seen some growth over the last 6 or so years. In electronic engineering, actually we're seeing a fall still. Chemical engineering down here has been climbing quite rapidly, but from a very low base. So there's a mixed picture going on for the individual disciplines. What's happening now with the advent of tuition fees actually is that this is starting to steady, where other university degree programs the applications are starting to fall. Actually, engineering is doing rather well. What happens when those graduates leave the university? Well, actually, engineering graduates have a good likelihood of getting full-time work. So engineering graduates do better 6 months after graduation at getting a job than all other graduates. So software engineering, chemical process, electronic, mechanical engineering all tend to do quite well. But there's another strange element to this, which is that actually they also, a proportion of them also do very badly at getting jobs at all. So more of them remain unemployed than the rest of the population, particularly in software and electronic engineering. So there's something going on here where in one case, engineers are more likely to be employed, but at the same time, they're more likely to be unemployed than the other graduates. When we look at the data, I'm not going to go into too much detail about this, but it really depends on the type of university you went to, the number of UCAS points you had at your A-levels or other qualifications, and the degree classification you had as well. But also, there's some quite kind of worrying trends around ethnicity. And if you are Asian or black as an engineering graduate, you're more likely to be unemployed than if you are an Asian or black student doing another subject. Similarly, if you're over 25, you're much more likely to be unemployed as an engineering graduate than for other subjects. You're more likely to be employable as a female, but not against other graduate subjects. And you are, and so on. So there are kind of 6 key issues I think we need to address within the engineering community and within the wider education community to connect students to engineering jobs. The first one is public attitudes. In the UK, this is the typical thing that people think what engineers are. So engineers are the people who fix your car or they fix your boiler. So there's a real issue with perceptions and understanding of engineers currently in the UK. So it's something we really need to get a hold of. The second thing is about teachers. Now this is about ensuring that we have sufficient supply of skilled teachers and ensuring that the teachers we have can be trained to use the right equipment, to enthuse and encourage young people to follow scientific disciplines and engineering disciplines. This site here of a teacher using a Van de Graaff generator is actually a very rare sight in education these days, because the majority of teachers actually don't know how to use the equipment. They don't know how to use this equipment. And actually there's very little time to do practical work, because the amount of material they have to get through in the curriculum means that they just haven't got time to do practical work like this. Employer engagement and careers advice and guidance is another major issue. In countries like Germany and France, there's an expectation that employers will be involved in the education of their young people. In the UK, they are customers waiting to have the young people for them. And they expect those students to be industry ready, to be oven ready, if you like. So we have to do much more as employers to improve the kind of engagement that we have in schools. And we also need to seriously improve the careers guidance system in education. There are all sorts of issues around qualifications, curricula and assessment. We assess students to an inch of their lives in the UK. Everything is monitored, everything is assessed, and it doesn't cultivate a kind of the kind of characteristics that we're interested in for engineers. So we teach them facts and we test facts. We don't teach problem solving, creativity, all these different critical thinking skills that actually are useful for engineers and for the rest of the people in the economy. Finally, I just wanted to briefly mention apprenticeships. And we talked about an alternative route rather than academic route. So we're very supportive of the government's drive towards increasing apprenticeships. But actually, when you look at the kind of increases in apprenticeships we've seen over the last 5 or so years, they've been in business and administration, health and public service care, and retail and commercial enterprise. Actually, there has been some growth in engineering and manufacturing technologies, but ICT and construction are right down there at the very low level. And actually, when you start to look at this data a little bit more in more detail, what you see is that the increases in engineering and in all of these are actually with over 25-year-olds. So it's people who are already working, being put on apprenticeship training programs by their companies and to develop their skills. But we're not giving young people an opportunity, and that's what the data is telling us. So, in finalising, engineers are absolutely central to the economy. We drive innovation and growth across all sectors. We have serious issues with the supply chain, the supply of young people. But without engineering, we would be naked in a field. And I think that is a really important message to get out to the population at large. Thank you very much.
Rather a scary message, the idea of naked in a field, I would think. Well, David, that was a bit controversial. Delighted to have the local MP for Havant. Hopefully you know him well. David has recently, as you know, been Minister for Universities and Science, attending Cabinet in the coalition government at the very, very highest level for 4 years. Prior to that, he worked at the Treasury, Number 10 Policy Unit. He's also served as Paymaster General in the past. He's the Governor of the Ditchley Foundation, member of the Council of the Institute for Fiscal Studies, and written widely, his latest book, The Pinch, I can recommend to you. His Wikipedia entry states, due to his high hairline, his careful intellectual approach, and ties to academia, which I pride for myself, actually, David, because he has been referred to as the nickname Two Brains. I don't. I look forward to realising why you do, David. Please, David Willetts, the Right Honourable David Willetts, MP.
Well, thank you very much indeed, and it's great to be here this evening, and I really enjoyed what Colin said and Rhys said, and indeed, thank you all for coming along this evening on something that matters to me in many ways, and it is indeed a challenge for the economy, as we've heard. It also matters to me personally, because my father, who only died at the beginning of this year, in fact, the last time I was here, I was going to to register his death just round the corner. It was the last time I was in this area. But he had a great life, and he was a member of the Institute of Mechanical Engineers for 65 years. And in fact, no, I was after his first 65 years as a member of the Institute of Mechanical Engineers, he and I went together to the National Institute for an event. I was giving a speech, and he came along. And they looked out his original membership form. And I remember the story. He'd studied civil engineering at Birmingham University during the war. He became an engineering officer in the Royal Navy and joined the Institute of Mechanical Engineers here in Portsmouth in the spring of 1945 as an engineering officer about to work in the Royal Navy. And indeed, he was just caught at the very end of the war and remembers being fired upon when he was out in the Med. And the experience of being in the engineering room of a Royal Navy ship made him realize that civil engineering actually wasn't what he really enjoyed. It was mechanical engineering. He went back to the University of Birmingham. He did a mechanical engineering course and worked as an engineer in IMI in Birmingham for much of his life before he retired down to Emsworth. And he was very proud of that, and he was very proud of being a member of the IMechE. So for me, this has a personal element, which means that I care about it particularly. I wouldn't dispute Rhys's figures, and I thought they were a very useful basis for the discussion. But I would like to make 3 or 4 quick comments, then we can discuss. The one framework of analysis that was missing from his figures was gender. And when we look at the figures for people becoming registered engineers, MECEng in the UK, the percentage who are female is very low indeed. In fact, my understanding of the percentage of people working as fully qualified graduate engineers is that about 6% are female in the UK. If you really want to increase the flow of talent into engineering, you need to do far better. We all, not just you as engineers, but we in government and in politics, need to do far better at achieving a gender balance as a minimum similar to that in other advanced Western countries. We're actually doing worse than other advanced Western countries in all this. And if you don't recruit from the talents of half the population, you shouldn't be surprised if the flow of people in engineering looks a bit tight. So that then raises the question, why is it that we have a particularly poor performance of girls in engineering? And I have let me try out my explanation of this to see if you agree with it. The evidence is that in their teens, girls who are interested in sciences particularly are interested in medicine. What they want to do is cure the world and have a career in medicine. And that may be not particularly a feature of the UK. What is a particular feature of, sorry, I should stop saying the UK, actually, especially with Graham here. What is a feature of the English educational system is that we expect people at the age of 16 to take very big decisions about what they specialise in a way that very few other countries do. So you have to take decisions about what A-levels to do. So the girls who are interested in science and want to go into medicine as a result choose to do biology and chemistry and maths. They then advance up this route into medicine. Being a medical doctor, I'm very proud of the fact that I have removed the caps on numbers for numbers of students in almost every subject other than in medicine, where there is a cap on the number of people who can train to be a doctor on the argument that it comes at a particular high cost, and we can work out how many doctors the NHS needs. The number of places capped in medicine as doctors is much lower than the number of people applying for medicine. So these girls, and the vast majority of girls doing the A-level mix that will get you, the vast majority of youngsters doing the A-level mix that get you into medicine are girls. So we've now got a group of girls who at the age of 16 have decided by and large to drop physics. 25% of the girls who get an A star in GCSE physics carry on to do an A-level in it, a shockingly low percentage. They've given it up because they want to be doctors. They advance up this route, and there is then a cap on the number of medical students, so a lot of them can't then become doctors. However, 2 years ago, they gave up the A-level course in physics that would have made it easy for them to go into engineering. This is a shockingly inefficient and wasteful system, which successive politicians have been complicit in it. We're complicit in it because of the media pressure that A-levels are the gold standard, and we can only therefore have 3 or 4 A-levels. Most countries do not expect people to specialise. I agreed in a way with Rhys's point about career information, but the trouble is in Britain, in England, the career information is even more important because we're expecting young people to take far more significant decisions than they have to do in most other countries. Now, if you may have to wait a few years for us to sort out A-levels, but there's something you can do in the meanwhile. I don't believe that there should be a requirement on A-level physics to do engineering. And I think engineers should learn from what classicists have done. Classics was in serious decline because in the old days you had to have A-level Latin and A-level Greek in order to do classics. The classicists realised that their market was going to be incredibly small if they required this, and they have put a lot of effort into making classics appealing to people who have not studied Greek or Latin at school, including giving opportunities for them to catch up and do it at university. I believe that a young person who's got pretty good A-levels in the sciences, even if tragically, regrettably, they have dropped physics, I think it should not be beyond the wit of man for a university as part of its first year in engineering to bring you up to the levels of physics that you need in order to do engineering. So there is a long-term solution in terms of the change in education policy. There is a short-term solution in terms of the flexibility of university recruitment. And I think that the final way I would help try to tackle this problem is, and it was absolutely at the heart of the presentation you've seen, engineering is a way of making the world a better place. There are lots of ways of making the world a better place. Curing sick people is a fantastic way of making the world a better place, but it's not the only way, and increasingly we will find that curing sick people requires sophisticated bits of equipment made by engineers. So there's also a point about the aspiration. So that's my first point. I think it was a pity that gender wasn't in the discussion earlier on. My second point is about, and links to it actually, is about practicals. We heard this argument that there's people who train as an engineer, then don't work as an engineer. And there are several reasons for this. One reason, and I think this is where, again, it was a problem that we were able to tackle, I hope, eventually, but it took time. I don't believe that the resource behind a student doing engineering properly captured the costs of delivering a university engineering course if they were to use the latest equipment and be job ready and have practical experience. There is a kind of 4-tier structure, or used to be, of higher education grants, which meant that higher cost courses did get more grants than lower cost courses, and that carries on. We pay grants still for high cost courses. But I didn't think engineering was properly resourced. And I remember a conversation with the chief executive of a German energy company. And I said to him, you recruit British engineers, you recruit German engineers, what's the difference? And is there a difference? He said the British engineers and the German engineers are by and large studied the same textbooks and know the same stuff. The difference is I would put a German graduate engineer in charge of one of my plants overnight. I wouldn't a British graduate engineer. And I said, why not? He said, because the German graduate engineers will already, at university, have been working on equipment very much like the equipment in my firm. They'll be familiar with it. They'll have the practical experience. I can't be so confident that is true of British engineering graduate. The more that you teach engineering on paper, because it is cheaper to teach engineering on paper, the more you produce actually systems analysts. And systems analysts are highly employable in the city. So the structure of engineering education has meant that engineering has been a training for absolutely those non-physical engineering jobs. That is the way in which engineering education, with a fall in resource per student, which we have seen in general over the past 15 years in English higher education, has developed. So it's very important to increase the resource per student, particularly engineering students. And what we did with our university reforms is, first of all, the 9,000 fee, which of course no student pays up front, but the 9,000 fee means there is more than replaces any loss of grant. So that the 9,000 fee actually means that each student now at an English university has more resource teaching him or her than there was before the changes, regardless of subject, which I think was a useful step forward. Then in addition, I had this very conversation. The last 5 minutes is what I went and told the Chancellor. I reported this conversation with the Chief Executive of the German engineering firm to him, energy firm to him. And I said, we are under-resourcing in the Band B, Band C, the engineering, the costs of engineering. I need some money from you, O Chancellor, so that the extra grant that goes with an engineering student is increased, so that there is more money for their education to be properly resourced. And 18 months ago, he agreed that. We put the extra money in. He completely saw the point. And the final thing we did is we provided an extra £200 million of teaching capital funding to go into equipping universities with new equipment so that they could teach on up-to-date kit. But we set 2 conditions for this competitive funding. The first condition was we said we would like universities to go out and find corporate and business partners who would put in a similar amount of money. It can be support in kind, so it can be going to the Royal Navy or Rolls-Royce or whoever and saying, please will you give us a piece of kit that we can use or contribute to the cost of a piece of kit. So they have to find a corporate partner that is going to put in a matching amount. And secondly, they had to show in the competition what they were doing to recruit women into engineering. They had to show what initiatives they were taking so that in future the distribution they would be attracting more women into engineering than they have in the past. And that initiative is also underway, and it's an attempt to get university engineering departments properly funded and properly equipped to teach with modern equipment. I think that the final point I would make is just one can always speculate about how many engineers a country needs. The one chart that Rhys put up that I wasn't persuaded by was this incredible sort of fan chart of all the extra engineers that are needed. And Colin, let me live up to your caricature. Which is, look, I understand there's public policy, I understand there's public services, I understand there's a need for public expenditure, but I also do actually think that by and large markets work. And that particularly is true of the English labour market, which is one of the most flexible labour markets in the world. So my first question when I see these charts is, okay, how do we know this? And if this is happening, where is the signal in the labour market? And what I look at is not speculative forecasts about how many engineers might be required. I look at what is happening to pay rates in different professions to tell me where there are shortages and where there are hungry employers. And I have to say, at the moment, in general, there is not a labour market signal of a massive shortage of engineers, which would be shown by a significant inflation in engineering pay rates relative to other pay rates. So I think you have to persuade me why a mechanism that we are all familiar with in general is not working in this case. But again, I don't think that, I realise that wages are not the be-all and end-all, but I think you need to think about what we can do to ensure that the labour market functions, and if there are these demands from employers for large numbers of engineers, why it is not being signalled. Because graduates, perfectly reasonably, one of the things they look at is what are the wage returns to doing this activity as against others. And if you want more engineers and fewer lawyers, apologies for any lawyers in the room, for example, you might expect the relative wages of lawyers and engineers to have something to do with that. And if young people can see that lawyers seem to earn quite a reasonable wage and rather more than engineers, then engineering employers shouldn't be particularly surprised if smart people decide they want to be lawyers. And this is something which is ultimately under the control of employers. And they might just try using the price mechanism a bit more aggressively and seeing if there doesn't get a response. So my view is, if you look at what I've said, I think there's a gender issue, and we can work together and tackle it. I think there's an issue about practicals and access to the latest equipment, and working together we can tackle it. And there's potentially a pay issue, which is, I think, above all, where employers can do better. If they really are going to be this short of engineers, they should signal it to the most powerful single mechanism they've got. Thank you very much indeed.
Thank you very much, David. Quick reminder to everybody here and those at home, please tweet and Facebook your questions. We've got about 45 minutes to get some questions. The fact is, David, and indeed Rhys, we're having this meeting, and it's kind of interesting as to why, if the free market works, we're having the meeting. And I want to start with a question from David Hill, who is the outreach coordinator here at Portsmouth. Can we get the microphone to David? Spends his time trying to influence and stimulate this area.
Hi. As it's just been announced, I'm David Hill. I work at the University of Portsmouth as the outreach coordinator, and explain my job quite well. I'm here to help engage with schools and colleges and get students interested in technology subjects. So my question, there are a number of programs and initiatives that are currently running to try and engage schools and school students in engineering. How do you think these can be improved? And how can we persuade companies and universities to engage with primary and secondary schools over the longer term, not just these one-off short events that they seem to be doing, if there's not an immediate and obvious benefit to the business?
Rhys, do you want to start on that?
Well, I think actually there are a huge number of initiatives going on, and probably it's confusing the landscape for schools and for employers. There are so many different initiatives. I think we need much greater coordination of the types of initiatives and activities that are going on in schools. And the IMechE and the Royal Academy of Engineering work with Engineering UK and the Institute of Engineering and Technology, the IET, and the civil engineers in a program called Tomorrow's Engineers, which aims to do exactly that, to coordinate some of the school-based activities so that employers can look at the types of where there are schools near to them that are having initiatives, activities being undertaken by other employers, so that they don't duplicate efforts. So we can really spread the effort proportionally around the schools themselves. I think there's another serious issue, though, which is the pressures on schools currently. When a engineering company or a body like the IMechE goes into a school, there's always a cost associated with going into that school. It means if they're doing it during the school time, it means that some lessons won't be taught. Now, it depends. It might be that they drop down a curriculum for half a day, which means that certain subjects won't be taught. So there's always an opportunity cost for this curriculum to go on. But also, schools are under incredibly high pressure to deliver to perform against a very narrow set of criteria, usually attainment measures in Key Stage 2 in primary schools or in GCSEs in secondary schools. And it's those narrow assessment criteria that actually drive this behaviour to make sure that students actually get good grades in the subjects that they need, rather than developing a broader range of skills around creativity and problem solving, which I talked about earlier.
David, if it's not a stupid question, why do you think we're having this meeting? Do architects have meetings? Do lawyers? Why are we having this meeting, and why are people like David putting all their effort into stimulating this or distorting the market?
No, I wouldn't say that. Now, my view is that, as I try to explain, there are barriers, particularly, I think, for girls and young women getting into engineering. As to what employers can do in this area, we have got a network of STEM ambassadors who do a fantastic job, and which is, I think, now about 40% female. And these are people who are working in different aspects of science, but absolutely including engineering. And they're doing a very good job of reaching out to school kids, both primary and secondary. I think, secondly, there is an issue about the school practical, which Rhys touched on. There is, I personally regret that the practical has ceased to be part of the assessment process in engineering and science. I think that's a pity. But equally, I think schools did find practicals hard to deliver. And one reason for this is if you're a teacher who is only doing that particular experiment or using that particular piece of kit at one point in a course, you may only be turning to it twice a year, or perhaps even once a year. So you're not comfortable, or your repertoire of the type of practical work that you do becomes very narrow. You endlessly repeat the ones that you're confident you can do properly. So I'm afraid I have come round to the view that you need much more a kind of travelling circus model of delivering practicals. You need people who do this morning, noon and night, and go from school to school and college to college, taking the kids through the practical experiments, because that becomes their specific area of expertise. So I think, again, there are things. All I'm trying to do is think of it as a system facing some engineering challenges.
Excellent. What are the challenges maybe? And I've got a question here from Natalie Desty, who I don't think is here, but I think we've got Richard Cookson, who is here to speak on over. One of the challenges might be the vocabulary, David and Rhys, and you've just used some vocabulary there to describe it, and I wonder whether we're maybe using the wrong vocabulary. Richard, can you give us the question? Can we get a microphone to Richard?
Thank you. Yeah, unfortunately, Natalie couldn't be here today, but I'm asking a question on her behalf. IMechE have been heavily involved, actually, in promoting a number of key schemes, actually, by sponsorship and promotion. And actually, Rhys mentioned the Tomorrow Engineers and STEM Ambassador Programme. David's point about women in engineering, I'm actually a member of the Women in Engineering Society, and a 6'6" male recruiter, you wouldn't necessarily think that would be the case, but it's actually about attracting, not just the female society in that programme. But in regards to Natalie's question, she posed, bearing in mind the huge numbers of engineers required, is it time to take the E out of STEM and promote engineering separately?
Rhys.
We had this very debate at the Royal Academy of Engineering about a fortnight ago, we voted at the beginning to see what the audience thought, and at the beginning the audience were largely in favour of taking the E out of STEM. Then we heard from a variety of speakers, including Professor Alison Wolfe, John Holman, who led the National STEM programme, Steve Holliday, the chairman of National Grid, Paul Westbury, the chief exec of Bureau Happold, who's a company that built the Olympic Stadium, the Eminent Stadium, various other venues, Millennium Dome and so on. And after the debate, the audience voted again, and it was 50-50, a dead heat. We couldn't decide between us whether to take the E out of STEM or not. I think we need to have a new messaging around engineering. I think that's really important. I think we need to draw out some of these other elements in engineering that do inspire and enthuse young people. And those are things like creativity, innovation, changing the world, helping solve problems, helping to meet some of the grand challenges that we face in the world over the next 50 years, including energy security, water security, food security. These are major issues, and engineers will be at the centre of the solutions for those issues. So I think there needs to be a new kind of messaging. But of course, ultimately, maths and science are fundamentally important for engineers. And so there's always going to be this kind of tension between taking the E out of STEM, but recognising the importance of the science and maths that underpins our work as engineers.
I'm going to come out, before we end this topic, I'm going to come out to you. Any comments here? Anybody tweeting anything? Please keep doing that. David, you're in a marvellous position here. PPE, Oxford, not an engineer. What vocabulary are we using that really upsets you or really offends you? Or are we just perfect with the way we're communicating this?
Well, I think on the question of the E in STEM, I think it would be a terrible mistake to take the E out of STEM. And you're right, I'm a layman, I'm not an expert, but I think the excitement, a lot of the excitement is the interaction of scientific advance and engineering and technology systems, and they mutually depend. Advances in engineering and technology often make kit possible that the scientists can then use to advance the frontiers of knowledge, which in turn feed back into the technologies available for engineers. Our problem is that we don't connect them enough. So when I go to the Large Hadron Collider, there are lots of British particle physicists. There are not many British people who helped make the kit, but it is an incredibly sophisticated piece of equipment, largely made by German engineers, not many British engineers. So that problem is precisely that we're not making the connection. I think think of the opportunity next month, the Rosetta mission. For me as a layman, the idea that a small satellite is going to land on a 2-mile-long comet 500 million kilometers away, which we don't know whether it's going to be landing on concrete or candy floss, and have had to design a system for the lander which will have close to zero gravity because the comet is so small. We have to design a system for the lander to remain attached so it can send signals to the orbiter, which in turn will communicate with Earth. Now, we're doing that because of the excitement of trying to understand the origins of our universe, but it is also a fantastic engineering challenge, and I want that event next month to include engineering as part of the project, and it'd be absurd to try to sort of divide it up between different disciplines.
I do remember David speaking at the Royal Institution and saying that kids only find two things interesting, space and dinosaurs. So out of those, and Rhys,
that is indeed the two things that really do get them interested early on.
Yeah, and I do remember someone suggesting that we put a dinosaur on a rocket. I totally agree with you, David, but I think one of the issues we have is this public and media and commentator perception of engineering as being a low-skilled, dirty manual type trade, if you like, and science being this kind of more high-level kind of intellectual pursuit. And I remember when I saw on the news the Rosetta mission when they were going into the final orbit, David Shuckman, the BBC science editor, talked of it as a science project. This was an amazing science expedition that was happening. And actually, all the way up to that point, it was engineering. There was no science involved up to that point. The science will happen when the Rosetta probe lands on the asteroid and it starts measuring. Up to that point, it's an engineering mission. And yet, engineering's not been mentioned once. Last week, the Evening Standard celebrated the Times London 100, and there was a focus on science and technology. Now, we often talk about technology as this kind of new, great kind of economic driver. And technology is a product, it's an output of the work of engineers. And in the editorial piece in the Evening Standard, there wasn't once a mention of engineers as the deliverers of technology. We often talk about Google and Facebook and all these tech companies. We have Tech City in the east of London. These are engineers doing this work.
Somebody interrupt him. Let's have a question. What about stimulating interest in kids? Anybody want to say anything, their views about stimulating interest in the next generation?
Hi, Keith Parkin. I'm CNG IMechE. Right, in terms of that, I'm also a STEM ambassador, and I proudly wear the badge. I don't know how many others do. And we do an awful lot with kids. On the thing about if you want to change STEM, I don't think we should take E out. I think we should change M to manufacture. Because maths supports science, technology and engineering. And the sum of that is manufacture. Manufacture is you then make something. You use your knowledge and you produce something. You get kids involved in it, right, and it works. That's what they want. Kids want to see how you do things, what you can do with it. Right? And I think that's where we should put the focus instead of arguing between science, technology and engineering, because all we're doing there is breaking parties apart and we're going off separately, and the sum of the parts is greater than the whole, isn't it? And if you break them all out, we're just going round and round in circles and doing ourselves no favours, because they all link. Not only am I an engineer, I'm a polymer scientist as well. I did 2 technical grades. We can do it.
Yeah, thank you very much. Sophie, behind you, there's another comment up here. Yes, please clap if you agree with the... or boo!
Hello, my name's Takunda. I'm one of the student ambassadors for the university, and one of the opportunities we do get is to go into schools and talk about courses. And one of the things I've noticed while talking to these children is they don't actually get to see engineering in their schools like periodically. What they do get is the one-off shot where someone comes in, talks about engineering, but as soon as they leave, so does the engineering talk. They're then staying with their science, their maths, and their usual subjects. And if they do engineering, it's usually in their design technology classes, where the teacher just gives them a piece of wood and they make a box, and then they walk out, and that's their lesson about engineering. How can we then give them more lesson plans that would then give them more about the modern engineering, not the usual DT that they just used to of just a nut in the bolt, and get them more interested?
Okay, thank you. Can I ask you a question then? Why do you think they don't do that? You're telling them to do that. Sorry, can we go back with the microphone? Why don't they do it? They're well-meaning people. Why do you think that doesn't happen?
I think there's a big stress on school budgets. And this has been seen a lot. For example, my secondary school. It used to be classed as a technology college, but because of funding, they've had to drop it from being a technology college to being a normal community college. So I think if we get more funding for engineering, for schools to have better equipment, I know that we used to have a lot of lathes in the school, but due to them not being able to afford to keep the lathes running, the technicians that will be helping the students, they were not able to carry it on.
Okay, lovely, thanks very much. Well, I can't, oh, Nicola, you just a quick one right in the middle here. Rhys,
Nicola T, just an ordinary member of the IMechE, and I do want to ask a question later, but can I just say the most brilliant thing of the presentations we've heard so far is Rhys's reference to CBBS. As an ex-teacher, amongst many other things, I do firmly believe, and I'm also a psychologist, in Sir Francis Xavier, who said, "Give me the child to the age of 7, and I will give you, unfortunately, the man." But I'm afraid all the evidence shows that even by the age of 11, children already have very firm views on engineers being people who repair cars and girls who do other things. And until we tackle, my suggestion is, of course we should tackle older, but I just want to congratulate Rhys. I think you've got it absolutely right.
We've got somebody behind you who wants to talk about age as well, by the looks of it. I do want to move on to government. I can't let Right Honourable David Willetts go without talking about government, so I'm going to move on to government.
Hi, Adam Hawthorne here. I'm a chemical engineer. So, hello everyone.
Welcome.
Thank you. No, I just wanted to comment that a lot of what we're emphasizing is actually bringing the experience of what it is to be an engineer further along the talent pipeline, further upstream. I think one of the biggest sort of things that we could do collaboratively is to try and encourage a lot more industry placements and work experience schemes further up the school chain for all the boys and girls to be inspired.
You've got nodding. David, did you want to comment on that?
No, I think it's, I agree. And I think it is, and the previous guy, your point about how your technology college has become a community college, I recognise those pressures. I mean, I think we should give a bit of a plug to university technical colleges. I think they are an initiative that could help in this area. But I also agree that the opportunities to experience industry is very important, provided that industry really grab them and make it interesting. Remember, there is a downside. You can, if this is your moment, taking the lady's point, that this is a moment to shape perceptions, if you mess up, if you make it boring, if you have the person that you're edging out of the firm say, I know, why don't you do the school visits, you will have had the wrong effect. So it's no good just having a program. It's got to be a bloody good program with the right teaching materials delivered by the most dynamic staff.
Okay. Let's move on. I can't hold back any longer. Tom Middleditch is here. Oh, Rhys?
Well, I was just going to add one final point on the DMT. We can, but I just want to make one final point to Tom, sorry. Which was the government very kindly allowed the engineering profession, through Education for Engineering, to rewrite the design and technology curriculum for schools. And as of this September, through Education for Engineering, we developed a new curriculum for all schools in England to teach design and technology, which will be much less about building bird boxes and clock faces and things like that, but actually solving real problems. And so we very much welcome the government's support in allowing us to do that.
Okay, no, fair play, thank you. Tom, let's start on infrastructure, please.
Tom Middleditch, Chartered Engineer with the Institute of Mechanical Engineers, and also the local area chair for Portsmouth and Isle of Wight area. My question on infrastructure is, how do fellow engineers feel about trying to exclusively offer national infrastructure projects to UK-based engineering companies to protect our engineering interests? Does this make good economic sense, or would we be wasting taxpayers' money?
David, I've got to ask you, why don't we just have make-work projects in this country that engage engineers and bring engineering into people's lives by modernising our infrastructure?
Well, I mean, I want to see our infrastructure modernised, and we are investing in it, but of course we need to do more. I have to say, I don't like your way of proceeding. I mean, it's kind of, well, and again, this is just a matter of your political beliefs. I don't believe in protectionism like this. And I go on trade missions with the Prime Minister and the Chancellor, where we have got Arabs and builders and engineering firms trying to sell in China and Brazil and across Latin America. And what if everybody did this? I mean, we are an exporting nation. We are the world, as a percentage of our GDP, we still export more than just about anyone else. And so you completely cut the ground from under the feet of anyone trying to sell services abroad. And we should have confidence in the competence of our own people. You don't want to, and the worst possible thing to, if we want to build up our pride in engineering, say, they lose out to the French and the Germans. I mean, the only way they can get a crack of the whip is if we ban the French and the Germans, which, as I say, would be completely illegal anyway, from kind of bidding. Now, there are smart things we can do on infrastructure to support our growth of it. But the idea we just have a sort of nationalist barrier, I mean, we're members of the World Trade Organization. You just can't do economic policy like this now. What you could do is be smart about distinctive national characteristics. And let me give you an example. And it's, again, something I was working on. The most significant single cyber attack publicly recorded in the past 5 years was an attack on the Aramco Saudi oil fields, which nearly worked. And a key vulnerability of infrastructure, therefore, now is the software programs that are required to operate them. And if you are running a city in Brazil or Hong Kong, what you worry about is an attack which means that your sewage system breaks down or whatever. We are very good at cybersecurity. So the challenge is, and instead of just thinking of it as kind of conventional engineering, say, right, our infrastructure that we are offering to build you your power system or your sewage system or equip you with your rolling stock, whatever, will have the world's highest standards of cybersecurity. And if you want high standards of cybersecurity, come to us. It's a feature of our infrastructure. That's the smart way to try to gain export share, not just trying to say, well, we'll keep out foreigners.
Rhys, I've got to say high-speed rail. I've got to say that China invests more in renewable energies than the rest of the world put together. What's the Academy's view, or what's the profession's view on the need for us to do this stuff as a capital investment with a long-term return?
Well, I think, I don't know if I should be speaking on behalf of the Academy now, but I think we do need to increase our investment in infrastructure projects, absolutely, but I totally agree with David that, you know, we can't have a protectionist kind of mechanism to ensure that UK companies have those projects, because, well, for one, it is illegal. I think, and I do agree also that actually the way to do it is to make sure that we are the best at developing the technologies and the infrastructure and the engineering capability to deliver those projects, and that we are the best value for money. So I would say that actually it's about improving our engineering, making our engineering the best to win those projects.
We've got somebody in the audience who's going to be studying engineering next year. Adele, I think you've got a question about couldn't the government make it slightly easier for you to do that?
Thanks, Colin. So I'm Adele O'Callaghan. I'm studying in my last year of Portsmouth High School, and I've just recently sent off my application to study chemical engineering with any luck. And I pray. My question is, if we are trying to encourage the study of engineering by more students, what incentives have been considered? Might meritocratic scholarships or universal tuition fee relief be offered to engineers and STEM students, perhaps related to the final grades received? Because I've done a lot of digging, and the only scholarships I've been able to find are from the University of Leeds, which are offered for achieving over your offer for studying there. And apart from that, there are very few I can find in relation to my course, except for a new one offered by the IET. So why is it so difficult to find any other forms of scholarships or bursary, in particular to engineering?
Rhys, you've got to go first. You give lots of scholarships.
Well, the IMechE is too tight, that's the problem.
Oh. No. Don't encourage him.
You fell into that one, Colin. You fell into that one. It's, well, probably there just aren't any scholarships. That's why you can't find them. There are a couple of issues, I suppose. Firstly, the graph I showed earlier of engineering graduates in the UK actually is starting to maintain a steady state, whereas other disciplines are starting to fall. And so actually, young people, students thinking about their degree programs are actually seeing engineering as a valuable opportunity because it will enable them to secure a job at the end of it. So that's one element. So actually, there isn't really a need from the government's perspective, I suppose, to encourage people to take engineering degree programs. Also, we see engineering graduates, and this comes back to David's point earlier, actually we are seeing increasing wage returns for engineering graduates in the marketplace. So engineers are, 6 months after graduation, are paid the second highest of all the disciplines in higher education after medicine, and similarly after 3 years, and they rank in the top 10 for lifetime earnings as well. So there are suggestions that engineering degrees are valuable for young people, and so the suggestion that government might soften the blow is unlikely to run, I guess. The other issue I might say is that actually we see engineers taking their degree programs and going off into other sectors. What we might want to see is perhaps tuition fee waivers or something like that for PhD students, where we do actually have a critical shortage for engineering. So maybe for higher degrees or something, that might be an alternative option, where there's not so many either.
David, it is the case that government does encourage, it's not true in some disciplines that there's fees are waived or paid back or something. There are some incentives given, aren't there?
I don't, well, we certainly don't. Individual employers can, but the government doesn't. And I hope the young lady does go ahead and do her chemical engineering. But the crucial point, and we can have a conversation afterwards about university finance, but the fees are not fees that you are paying up front. The loan is not a loan like any kind of overdraft or credit card loan. It is a graduate repayment scheme. If you are in work and earning more than £21,000 a year, you will pay through income tax an extra 9% on earnings above that. So if you're earning £25,000, which is not bad for a recent graduate, you'll be paying back 9% of £4,000, you'll be paying back £360 a year, £30 a month. That is, and as nobody pays up front, which I hope we have communicated to young people, there isn't the evidence. Indeed, we've now got record numbers of people applying for university. Nobody's being put off because nobody has to pay. So it's a kind of, I have to say, I don't agree with the analysis that this graduate repayment scheme is an obstacle to young people. In fact, I would actually turn the argument round and say, because we've now got a system in which the universities will eventually be funded out of the repayments from graduates, if they can afford it, out of income tax, that has enabled us to remove the number controls. So for the first time, until 2 years ago, Portsmouth University would have an instruction from the government. You will recruit 3,720 students, and if you're, whatever the figure was, or if it's 3,721, we will fine you. That was the old system. That meant that there was a limited number of places for chemical engineers because they had people applying. We have got rid of all that. There is now no limit on the number of students that any university can take on, and they bring with them, through the fees and loan system, the resource to ensure they're educated. And so then, just to finish, because I say, actually, all these examples I'm giving, I'm just trying to apply an engineering discipline of systems analysis to public policy. So once you said there is a higher cost, public expenditure cost, for an engineering student in order to solve a problem which I don't actually think exists, you then create an incentive for government to control the number of students. So the first thing you do is say, is there an infinite number of these bursaries and scholarships? Should we decide a limit? Should we fix the number of places that are covered by the scholarship? And before you know where you are, instead of got a growth of engineering students, you've created a new public expenditure discipline to limit the number of people eligible for this bursary. So so I don't think it would work, but I think you certainly do need, if there is extra resource, what would I want to spend the money on? I actually do think that a crucial point is these type of conversion courses, so people from a wider range of A-levels can study these courses at university and also make it easier for them to convert to them during their time at university. Another point which I didn't have time to make during my talk, but we also in England, not only do we expect 16-year-olds to take this bizarre decision that most other countries don't expect them to take, we also expect an 18-year-old to specify that they're going to do chemical engineering at university. If you go to Penn State or Harvard or anywhere in the US, California State University, they don't expect you to say at the age of 18, I'm coming here to study chemical engineering. You can do major and a minor. You can say, I'm really interested in Shakespeare. I want to do the Shakespeare course, and I want to do the human genetics course. And at the end of the first year, you may say, I think I'm going to major in chemical engineering now. So the decisions about what you're going to study at university are also far more constrained than most other university systems. And that is because our system is designed by the specialists in those disciplines who want people who already know a lot about their discipline to educate further. The American system is one where all the different departments are throughout your time as an undergraduate competing for your custom. And they are thinking, if we make our chemical engineering classes really pacey and interesting, we might get more students who decide to come and do chemical engineering in their second year. That, I'm afraid, is another example of competition. I apologise. But that enables you, instead of saying people have taken these big decisions at 16 and 18 and now we're all tied down, It enables you to have a far more open system, and it also generates competition in teaching quality within a university environment, which doesn't exist if people are pre-committed when they arrive.
This has got people going now. I've got two folk in the audience, the chemical engineer, but I've also got this chappie here who's going to do something. Sophie, can we start here?
My name's David. I'm currently third year in a course of mechanical engineering at Southampton University. But there's something that I'm really passionate about, and I'm really big on doing my volunteering, getting involved and inspiring engineers as much as possible. Now, the thing that I really want to do is I want to work in the industry, and I know that experience is absolutely paramount for this. But when I was applying to university, I was on the brink of the 3,000 to 9,000 jump, and I'd been applying for a year in industry. Everything was sorted. I had everything going for me. I'd been accepted on a scheme, and then I had to turn it down because I could not afford the 27 grand increase. And that for me was pretty despicable, because I've now missed out on the opportunity for a year in industry thing, and that was not a consideration. And if I deferred the extra year, it would have been the extra £27,000 hit over the 4 years of my university course.
You didn't have to pay. Well, you made a terrible mistake. You never had to pay any money up front, and indeed, your repayment terms, I actually spent a lot of time with sixth forms where people were having to make a choice. In the old system, you'd have been paying 9% of earnings above 15,000, you'd have paid it back in a shorter time. Nobody had to pay. You didn't have to pay. If you'd been in a well-paid job, the 9% of earnings above 21,000 should not put you off and does not put young people off. I'm terribly sorry you were so badly advised.
Yeah, it was more the fact that I had no choice. Like, the year in industry is an industry recognised scheme, and it is a fantastic scheme because I know people that have been on my university through it before. And the opportunity was taken away from me because I would not have been able to afford that over the long term, because I would have had to pay it back at the end of the university, but it is an extra 27 grand on top.
Out of your earnings through income. Look, it's a 29% rate of income tax above a threshold of 21,000. When I left university, the basic rate of income tax was 35%. It is not the case that paying, if you're earning 25,000, £30 a month, as a graduate, and if at any point your income falls below 21k, you don't pay it. We've lowered the fixed monthly commitment is lower than under the previous system. The people on 3,000 had higher fixed outgoings than the people on the 9,000, paradoxically. It is not the case. That is not a reason for not going to university. I'm sorry, and all I can say is, if any person didn't go to university because they thought somehow they couldn't afford it, when there is no upfront payment and there is simply this income, that would be a tragedy. And I put a lot of effort. We had no wider media coverage, so I quite recognised the parents don't understand it. They just follow what they read on the media. What we did is we spent the limited communication budget we had sending recent graduates to every school and college answering the questions of the 17-year-olds about the realities of the system, and the number of people applying for university has grown every year under the new system.
And if I might defend the coalition government, they're getting criticised hugely because students aren't paying back and they're seeing this as a subsidy of universities. The chemical engineer, do you still want to say? Or we've got somebody at the back here.
I just wanted to share...
Can we have the microphone, please, sir?
Hello again. I just wanted to share the observation that chemical engineering actually does a lot better in attracting women in terms of careers. We actually have an oversupply of people applying for chemical engineering courses, as I'm aware a lot of other engineering courses have at the moment. We actually expect our problems are more aligned to retaining those members once they leave the university courses. One of the activities that's been a privilege that we get involved with, and members groups and others get involved with, is actually going into the universities and telling the students how to come across and apply for work. That's a valuable exercise, which to me is something that needs to be sort of highlighted as part of a solution to retain the excellent capability that's coming along with this talent pipeline, to not make it leaky.
Let me just finish a couple on David or Rhys. I want it's continuous professional development. We're getting around to it in engineering. We've kind of got our heads around. It's going to be mandatory pretty soon. Could you give us zero VAT on training courses? It's come off. It's not me. It's come off the internet. Could you do something to encourage us to continue to develop and progress?
Well, we have still got rather a large budget deficit, not as bad as it was, but we have to collect some taxes from somebody, and and the trouble is, when you need to finance a large-scale modern welfare state, you can't just tax vice. People always say, I used to get all these people who said, I'm doing something virtuous, you don't really want to tax me. When you need to collect almost 40% of GDP in tax, you have to tax some things that you also quite approve of and are desirable. But on CPD, I do think there are arguments for improving the incentives for universities to stay involved with training of their recent graduates. And one of the things that I always found perplexing about so many training courses and training schemes, and I used to go and address some of them, is they happened in kind of hotels. A lot of time people go off to some sort of, I always was surprised. I thought, why aren't they going back to the local university? Why isn't that seen as a place you can have CPD? And this would actually require a change in the law, but I would love, for example, graduates, with their consent, the university to be able to stay in touch with a recent graduate and have their data from the student loans company. At the moment, the law forbids any communication of data about graduates from the student loans company to universities. I would like it to be possible either for a university to say, hang on, that guy or woman has been unemployed for a year, or they've been earning below 21k for a time. We always haul them in and see if we can help out, or alternatively saying, bloody hell, he or she has been earning 100,000 a year for several years, perhaps they might like to become a donor. But those, which is the kind of interventions, again, you get in the US, and there are massive information barriers because of this refusal, this current bar goes back to the Blair legislation. So there may be ways you could get universities more engaged, and I would love universities to do more in this space.
Lovely. Well, we're just about come to the end of the formal piece. I'm going to allow, just for the privilege, because he's done all the hard work, I'm going to let Jason ask the last question so we end on a positive note about grand challenges.
Thank you very much. What will be the greatest challenges that engineers will face in the future? How do you train and develop budding engineers to tackle those problems rather than the problems of yesterday? How do we ensure engineering course curricula reflects tomorrow's needs and not those of yesterday also?
Rhys, you're a positive man always.
Very positive, Kevin. I think we need to just re-evaluate the way we teach young people in schools. And we kind of, there's a some of you may have heard of the Marshmallow Spaghetti Challenge, where various groups of people are asked to build a structure as tall as possible to hold with marshmallows and spaghetti. And interestingly, the best people who build these structures are engineers, followed by architects. But the third group are primary school children. And primary school children beat chief execs of major organizations, they beat MBA graduates, they beat lawyers, all sorts of
parliamentarians.
Parliamentarians, no, without a shadow of a doubt.
We just eat the marshmallows.
And yet what then happens, these are primary school children, and then what happens is every stage of our education system beats this engineering capability out of the children by siloing them in different disciplines, by teaching them knowledge and facts, and not these kind of creative problem-solving type disciplines. So I think we really need to re-look at the way we educate children from the bottom up in this country to nurture those innate talents, those innate engineering talents that they all have. We're born engineers, and yet somehow our education system kills it. So that would be the biggest challenge that society faces, to create more engineers. The greatest challenges engineers face, I suppose, are those issues I mentioned earlier in terms of, with the increasing global population, how do we make sure we have enough food, water and energy?
And David, as a non-engineer, leave us on a high. Tell us something nice about ourselves.
Yeah, and that's no problem. I do think that engineering is at the heart of any modern economy, and certainly something where my thinking has changed in the past 20 years, and where I think the British mood has shifted, is that we went through a kind of preoccupation that the future was just services. And it's absolutely clear that advanced manufacturing is very important and that a modern economy can't simply live on services and needs also to be good at making things. I think sometimes actually we've rather done ourselves down because the percentage of our GDP that goes in manufacturing is about typical for an advanced Western country. We have this extraordinary case of Germany, which has a very unusual industrial structure, in many ways a much more unusual structure than ours. But anyway, making things matters. And so on the challenge, I think the challenge is the interaction of human and machine. And that is actually reinforces some of Rhys's points. It's why multidisciplinary understanding and teamwork is so important. So, for example, I've got very interested in robotics, autonomous systems, which in turn feed through into a kind of Internet of Things. And what is crucial is they're going to be, so for example, at the moment robots are basically defined as equipment. And under health and safety at work, you have to put equipment behind a cage. But you really want the future is going to be robots working alongside humans. And how do humans and robots interact? I wanted a competition where we might say the competition is the robots are all released at Hyde Park Corner, and the first one to arrive at the Olympic Park wins a prize. But then you think, well, hang on, what if they tread on a baby en route? What if they walk in front of a car and the car breaks and someone has an accident? How do you program in all the interactions with humans that follow from that? If you have a driverless car, which is programmed to stop as soon as it and does that very safely, as soon as it has a cyclist or a pedestrian close to it, then within a year we will understand the conventions of driverless cars and be happily walking out in front of them. In other words, it's the interaction of mechanical design and human behavior as the mechanical kit gets more and more flexible and more accessible and closer to us, which will mean that understanding how human behavior interacts with it will be the challenge. And I think that's why engineering is crucial, but engineering plus the social sciences, plus psychology, all that is the future.
Thank you very much indeed. The time has zipped by. I think both David and Rhys can stay around for a few minutes, but we must end the formal piece now. So please join me in thanking hugely Dr. Rhys Morgan and the Right Honourable David Willetts MP.
Thank you very much. Thank you, David. It's good fun. Good fun.
Good. It was a good turnout. Good for IMechE.
Yeah, very good.
Thank you very much.
So, thank you very much to everyone. Sorry, before you disappear. Thank you very much for our speakers and for our chair today. Just got a few small gifts of appreciation for them. First of all, for the chair, who conventionally has something that he can enjoy later this evening.
Thank you very much.
Thank you very much. And also for each of our speakers, just to remind them of who did organise tonight and who they might be interested in getting involved in the future. Some Institution of Mechanical Engineers tankers.
Thank you very much.
And to Rhys. Also this time I'd just like to take a few minutes just to, as well obviously we thank the people that have been speaking at the front, but also I'd like to thank a few of the people that have been involved in the organisation of today's event. First of all, I'll start with the University of Portsmouth. Thank you again for the use of your venue, but also thanks to some of the staff members that have worked tirelessly to help us organise and also for some of the funding towards this event, including Marika and Sophie Hall. We do have some gifts, but we'll give those out afterwards. Jason will come and see you. I'd also like to thank the Institute of Mechanical Engineers, obviously, for myself, but for the funding that's been provided and also the guidance, and also a couple of people from region as well, One of those being Gavin at the front, who's been tirelessly behind a laptop, making sure that all the IT and questions and everything else has been working between himself and the chair. And also to Nick Shulkins, who's the Wessex Region Chair, supporting all of the area committees in this area. Also to Microsec, who, for people here, you might not be aware, there was a launch page as well, which had all of the audio going to it and all of the Twitter feeds, Facebook, etc. And that was for the people, particularly on the other end of the internet bits of string, who couldn't be here this evening. So thanks to them for their help with that. But particularly to the champion, Jason, who has made this event happen. I might be standing here thanking various people, but actually we should all be thanking Jason for all the efforts he's put in, because without him, we wouldn't be here this evening enjoying this event. So for all of those people, transport those home safely. I'd also like to take a few moments just to thank all of you for being here, for your attendance, but also for your engagement. So, you know, the speakers did have 10 minutes each to pitch their views on engineering in the future, but actually it was all of your questions and your engagement this evening that made this such a challenging and informative event. I think we've all gone away with some things to think about how we want to move engineering forward. In particular, we've had groups from, I know there's a number of IMechE members here, which obviously I'm pleased to see as the local area chair. There's also members of a lot of other institutions, and hopefully you all had an opportunity to go around the various stands downstairs to see what other engineers have to offer from the different sectors. There's also school staff and students, other engineers, and also a couple of people who honestly said, you know, albeit I'm not an engineer, I don't want to be an engineer, however, I'm interested in engineering, and obviously you are welcome, and I hope you learned something from this evening. I'd also like to thank those who listened online and also interacted online, and we brought some of their questions through. The event we've run this evening has been rather unique and groundbreaking in, you know, particularly all the IT, and Jason Crouch, thanks again, along with Gavin for making that happen, and thanks for all of you for trying to interact with this new way of trying to do things via social media, Twitter, Facebook, etc., to try and get those questions in and try and theme the questions in a fairly structured way through the engagement we had with you. What I would ask is that you do provide some feedback to us, because this is a model we'd probably try and use in the Institute of Mechanical Engineers, certainly within our local areas, and other people around here might also be inspired to use it in the future. We will send you some correspondence after this event, so asking for your feedback, so please do tell us things that went well and things that you think we could potentially enhance for the future. For those that you have been inspired this evening, each of you should have got a leaflet as you arrived this evening, which has a few of the events that we, as the Institute of Mechanical Engineers in this area, are running. So please feel free to attend our events. If you haven't got that leaflet, there'll be more downstairs, or grab anyone with a green badge who is a local area committee member, and we'll tell you about what we're up to over the next few months and year. For any of you that might be inspired to do a little bit more, IMechE members, I'll be delighted if you knocked on my door and said you wanted to be a member of the committee, so get a bit more involved in these sort of events in the future. I have to say that. But also for people from other institutions, we're really keen to do joint events where we try and get some of that jointery between different parts of the engineering fraternity, and actually get mechanical engineers going to chemical engineering events and interested in technology and all that sort of stuff. So please do come and approach us if you're looking to do some more joint events, and tell us what you're doing so we can advertise to our members. For those students in the audience, for students that are looking or already at Portsmouth University, if you're interested in getting more involved in IMechE stuff, please do get in touch, because we're looking to set up a young members group as well. A little bit of funding, a little bit of guidance. Hopefully you can go away and run your own events within for young engineers within your university, and also supported to the wider community here. For school staff and students, please do come and knock on our door if you're looking to do any sort of STEM event or want any guidance for that. Because amongst the IMechE membership, you know, those that are already STEMnet ambassadors or a variety of other initiatives that I'm aware of, we're always really keen to find some schools that are looking for engineers to come in, and that's certainly something we're looking to support within this area. And for anything else, please get in touch. All the contact details, website details, etc. are on that leaflet, or talk to myself or any of my team. One quick advert. Up on the big screen behind me, thankfully. One of our next headline region events is the Arnold Bart's Lecture. It's going to be held on the 3rd of December. And this is an annual memorial lecture which tries to engage with loads of school kids during the day and then culminates in a big evening lecture from a prominent engineer. This year it is, the topic is What a Difference a Web Makes by Professor Dame Wendy Hall, who works alongside Tim Berners-Lee to the assumption of the internet with the World Wide Web, and tickets now are available to book. But contact details are on the near you, and also on our leaflet. If you go through that and chat to any of my committee, we'll give you details of that. So at this stage, I'd like to try and bring the meeting to a close. What I'd like to do is invite up my other area committee members, scattered around the audience. If you come up now. Some of them look a little bit embarrassed. So this is about half of my committee, and you'll notice they're all wearing green badges, so please do come and talk to them afterwards. What we're going to do is we're going to go downstairs, and there'll be an opportunity for a little bit of networking, socialisations amongst ourselves. Please do use that opportunity to come and chat with us if you'd like to. If not, please use the facilities that are down there. Grab a leaflet if you're interested in future events. What I would say is that by about 8:30, the university, I think, would like us to clear out, so we've got about 15 minutes. Any assistance you can give to any of the stands to tidy up any of the stuff, that would be greatly appreciated, I'm sure. And if anyone's interested in a bit more of an informal feedback session, immediately on completion of tidying up, certainly these people here, or at least most of these people here, will be heading down to the pub, to the Ship and Castle, which is opposite the entrance to the historic dockyard on the way to the Portsmouth Harbour Station if you're heading off by train. And if you have no idea what I'm talking about because you're not local, please do feel free to follow anyone with a green badge or come and chat to me. But finally, I'd like to give a final vote of thanks to chair, speakers, and all of you for attending.